right? So what you're going to do after this week, right? Everybody's done field work wise on their tractors, correct? So if you're done field work wise, you can now enter your control points in your data. Couple of notes before we get started. Let's say you had a 4-point rectangular tractors. And this was your tractors. Over the course of 2 weeks, 3 weeks, one of those points got destroyed, whether it by landscaping or flooding, no worries, got destroyed somehow. You went out, you couldn't find it. All right. It was obliterated. What is important in surveying is that exact position, horizontally and vertically. So there shouldn't be any sort of math, trigonometry, calisthenics to, okay, this was destroyed, we reset it in the exact same place. Now, the odds of that are pretty much slim to none, and some just die. You're going to have to set up on one of your 3 known points, right? So you'll have to set here or there. Take a back site, get a new horizontal angle, vertical angle, slope distance, and reestablish coordinates for this. Okay, is that clear? Everybody understand why? Like the position has to be accurate. And if you're using trig to kind of force it back, when you plug these points into the data collector and you use backside at, you say I'm at point number 1, backsighting 2, and you did some sort of trigonometry magic to reestablish it, that error is going to reappear. It's going to show up. Okay. So you're going to want to set new coordinates for this, then take a shot to this and check an inverse between those and see how close you are. Does that make sense? It gives you a check on, like if you reset here, then pick up and move to here and check into this, it'll tell you how close you are. Does that make sense? Yes? No? Okay. Couple things when you go out and do your survey. If you have to, for any reason, re-level the instrument, okay, it's at a level, you bump the leg, whatever. Do you just pick back up again, or what do you have to do if you re-level the instrument? When you say set it up again, what do you mean?
I like to do it back in the beginning.
You don't necessarily have to do it from the beginning. You have to make sure you're over your point. You re-level it. But what is the next step after the instrument's ready to go? What do you have to do? Set 0, retake your backstep. You have to retake your backstep. Right? You have to reset it back to 0. Okay? It's always a good idea to have a sketch in your field book, even if you're using a data collector, so you can keep things straight. What point am I on? What point am I backsighting? Because that's what you need to know when you're using the data collector. You're going to hear people refer to these things as, there's 3 basic terms that are used. I'm going to send this one around. So you take a look at it, play around with it. It kind of takes the place of the field book, but not entirely. You still want the field book to have a sketch, take your notes, write down the crew members, the date, the weather, all that fun stuff for record. But all of the angles and distances and coordinates are going to be stored in that. So you don't have to do the math. Okay? You can actually do the traverse survey with that, but we're doing it another way so you understand how to get horizontal and vertical points. Or horizontal and vertical positions. Sorry. Now, you've got your points. We're going to show you how to load them into the data. I said around your building. Let's say this is your building. Okay. Do you have to shoot every single corner of this building? You have to shoot this point, this point, this point. You have to shoot all of them, yes or no? Not necessarily. Is it a good idea? Of course it is. The more points you can have, the better. The more accurate your topos are. But instead of having 8 traverse points, instead of 4, and you can get all of them but 1 or 2, what's your other option? What can you do? Let's say I can't get this point right here. What can I do? You can measure it with the tape measure, right? You can get this distance and this distance with the tape measure. Generally speaking, building corners are usually what? 90 degrees, right? So if you know the building does something like this, and you shot this point, and you shot this point, can you just make some assumptions about those angles and kind of build that? You're not going to be as, absolutely, but you're not going to be as precise if you shoot. So the take-home message is shoot as much as you can, but you might not be able to shoot every single solitary thing. That's what the field books, that's what notes are for. Take pictures, right? You're going to want an accurate map of what your building is and everything around it. Like I said, stairs, let's say there's a big staircase out front. You're going to want to shoot that. You're going to want to shoot steps. Landscape, you're going to want to shoot all that stuff. So there's a nice landscape with some trees. You're going to want to shoot all that stuff. You're making a map, you're making a picture. When you're all said and done, you're going to have probably a couple hundred points in that battle. You can probably record a crew that's going to go out and do this. If we were to topo the quad, you can have 300 points in an hour. If you're running 2 rods, like you can easily have that many. So I don't think that assigning, say, 100 points as a minimum is ridiculous, because you're going to have 2 weeks to shoot it and create it. But what you're doing, do you remember, like they even make them now for adults? Did you ever see the dot to dot books where there's like 500 little dots and you just go 1, 2, 3, 4, 5 dots? Yeah. That's what you're doing. That prism pole, pretend it's a pencil. You're drawing the picture with the prism pole. Now, do you have to go in order? Well, not necessarily. You can be random and shoot scattered stuff so long as you're remembering and coding it in there. In surveying, I don't spell everything out. I don't spell out building. I just do BLDG. I don't spell out sidewalk, SW. If it's a road and it's, there's no, does anybody not know what a curb is on a road? It's the vertical concrete on the edge. If there's no concrete or no block, right, we just put EOP. What does that stand for? Edge of pavement. What's BCTC? Bottom curb, top curb. So come up with your own nomenclature, but those are some pretty common ones. Okay. when you're shooting stuff, okay, polylines are just straight lines, okay, at one elevation. That's how you're mainly gonna draw it when you get it back, is with lines and polylines, mostly polylines. Let's talk about, everyone okay with this? Go.
Where are you shooting from? What's the setting?
You're probably, not probably, you're gonna have probably 25 to 50 points from each setup. You're gonna set up at each of your control points and shoot whatever you need to shoot from each of your control points. Now, if you're one of the groups that had to traverse over to get to your loop, are you gonna be shooting stuff back here? No, you're just shooting stuff around your building. Does that answer your question, Omar?
Yeah.
Great.
Do we still traverse over from the back part to get to our loop?
No, because you have coordinates now for your loop. I'm going to show you how to plug those coordinates into that data logger, and then you're going to say, I'm at instrument at 2, backsighting 1, and then you're going to start taking what they call topo points, or topography points, or multiple side shots. It's called different things. But what you're doing at that point is you're referencing, you're at this point here, you're backsighting here, and then all of your angles, you know, are, you're spraying out and hitting that however many times. But you're not writing down your horizontal angle, vertical angle, slope distance in the book. That is what's doing it for you.
Is the priority of this to just do like the building? Is it with the elevation of the land? What is what is the goal of what we're shooting? Is it just the building, or what aspects of the building? I just don't know, like three-dimensionally, like what you're doing. I'm just imagining one random points on the side of the building, and I don't know. I don't know how to put this together to a picture of what you showed us.
Okay, good question. The picture that I showed you of the survey that I, right, you need to have enough information to be able to draw an accurate picture of what's out. So everything around that building, you need to locate. So you need to shoot it with the instrument. Vertically, you're going to be measuring the heights of everything also, because you're going to be telling it what the height of the rod is. Because you're going to have accurate elevations on everything, you're going to be able to make a topo. That's not going to be part of the first assignment. I'm going to show you how to make a surface model with contours as we move through the class. But the idea is to grab enough shots that you're going to be able to draw an accurate existing picture of that entire building and what's around. As far as the three-dimensional model goes, all I'm really worried about is the finished floor elevation of the building and everything around it that either is a feature or has some sort of vertical review, like the steps. You're going to want to shoot those steps.
But like shoot what about steps?
So if we're looking down at the steps, right? You're going to take a shot here, which this is my ground, right? So you're going to take a shot here. Then you're going to take a shot here. Then you're going to take a shot here and a shot here. So then you're going to have your, because you know this is going to be at the same elevation. And then you're going to take a shot here. So for the steps, you're going to have 1, 2, 3, 4, 5 or 6 points, depending upon how many steps. You're going to have 5, 10, however many points you need to locate the building. Now, if your building has curves in it, we're going to talk about curves here in a second. But I'm not sure I'm answering your question.
I think I'm just generally confused and maybe I should do it in my question. Are we prioritizing both like like a horizontal two-dimensional distance as well as an elevation?
You're doing both. You're gonna do both. Because when you tell it the rod height, you're carrying the elevation, so it's gonna give you vertical information. It's gonna give you the vertical elevation of that. You know, this one could be 400, this one could be 400.75. This one could be 401.25 and so on. But if you're telling it the rod height as you go, or you don't change the rod height, then it's gonna do that math for you. So when you're carrying elevations in the battle line and you're shooting the center of the prism, it's doing the math, because in the setup, when we plug it into the data logger, you're going to tell it the height of the instrument. And then for each shot, so long as you don't change it, it's going to stay the same. It's going to be either 5 or 490 or whatever your particular rod reads. You got to look at the side of it and see. And that data logger will record the elevations for you. But you are going to need those elevations, because that's what's going to create the topo, the contour. It's the difference in elevation from spot to spot to spot. Now, some buildings around campus are very flat, right? From front to back, there's almost very little elevation change across. Markle is different. Markle tops up here, the back drops down to where the deck is, right? So it depends on your building. So if there's a question, shoot. Like with the data logger, it's just pushing a button, it records it, and you're on to the next step. Good rules of good practices, I guess, is a better way to put it. As you're out there, is if you're shooting a side, let's say, or something that's long and straight, even the building itself, we have this big building, it's long sidewalk. Am I okay with just a corner, a corner, a corner, a corner, a corner, a corner? If I want accurate contour, probably not, right? I probably want shots at a certain distance. In the field, typically we use maximum 50 feet. So I walk 13 to 15 paces. 1, 2, because for me, that's about 50. I'll walk around 13 or 15 steps, take another set of shots. So I'll get a shot here. So everybody see how that can add up. You know, you shoot it, record it, on to the next, shoot it, record it, on to the next, shoot it, record it, on to the next. And I'll show you how to do that with the data logger, but concept-wise, that's what you do. So you're probably looking to get a shot every 30 to 50 feet to get an accurate point cloud of everything that's going on around the building. Is that helping answer the question, or we're still conceptually?
I think so. I think I just had like the perception that every point you had like a point above every point in space, and it was like completely accurate, and like, like all the contour lines all the way around it in a way that was like perfectly accurate. And I just
We will, but it's not going to be as accurate as our trackers.
yeah. I'm just imagining like a fully detailed like topographic map you like give to someone hiking, and I don't know if necessarily it is like as specific and precise as I'm imagining it needing to be. I'm just imagining there's like a million points and you just shoot and realize it's not the case. So
Yeah, I mean, so actually what you're going to be doing around the building building is going to be more accurate than those hiking topos. Because those hiking topos are relying on, old school, they used to do LiDAR, or I'm sorry, current is LiDAR, the satellite data, and getting shots from satellite. The old way to do it is the old stereoscopic aerial photos. Anybody ever see those? Where it's an aerial image side by side. The way you see three-dimensionally is the way your eyes are spaced, and so what they do is they take two photos in an airplane way back in a hot air balloon, and you used to look through these things through a pair of glasses, and you could actually see the elevation. Pretty cool. But what we're doing in getting elevations at specific spots is actually going to be more accurate. Now, when you're locating stuff, when you did your traverse, I told you to locate the tip of the rod, bring it up, and then shoot the glass, right? That's going to give you the most accurate horizontal and vertical position. Do you have to do that for all of these little side shots? No. As long as the person's holding the rod, right, center of glass, shoot it, next shot. Center of glass, shoot it, next shot. Like every shot, you're not on the ground, right? Because the idea is to keep it moving. So you're getting as many shots as you can. So this is nice for long tangent stuff that's in a straight line, every 50-ish feet. Okay. Can I erase? Everyone's okay with this? Okay. Let's talk about curves. How many points do you need to accurately or reasonably accurately draw a curve? Good. At least 3. Awesome. Right. So if I have a sidewalk, and the sidewalk has a nice little turn, like so, and you can kind of see where those curves begin and end, right? If you were surveying this for the first time, do we all agree that 2 of the points that make the most sense are the beginning and end? Right? Okay, so we all agree on that. In surveying, you know what we call those? You might have had it, I might have seen it, I might have mentioned it. PCPT. PCPT. Point of sure. Point of end. Which one is which is directionally sensitive. What do I mean by that? If I'm walking down the sidewalk this and I get to this point, is that the point of curvature or the point of tangent? It's the point of curvature, it's where the curve begins. I go around, and then from that point on, it's a straight line, tangent again, point of tangents, point of tangent. Point of curvature, point of tangent, PCPT. So if I'm going this way, it's PCPT. If I'm going this way, it's PCPT. Everyone follow that? Okay. So Joy is absolutely right that to shape a curve correctly, you need 3 points. If you were doing this for the first time, would you shoot the radius point, or would you shoot some other point on the curve, say the midpoint of the curve? Absolutely. Every time. Anybody want to venture a guess why? You could, yeah, and it's going to be more accurate because if you're out there and you're like, yeah, that's about the center. Where is the center? Like, if it's a sidewalk, you can see better. Okay, that's about the midpoint of the edge of the sidewalk. And then you draw a 3-point curve. to shape. The other reason the point on the curve is better is because what if I have a sidewalk that's like this? So is that completely tangent? Like, have you ever been walking along and you know how a nice smooth curve, like ever see it where it's kind of got a kink in it, where it's not a smooth beginning to the curve, where the curve, you got a nice straight line, but then this curve kind of does something like this. Right? Where this is a non-tangential curve. What do I mean by that? If you drew a line from the center of the circle to the beginning, and so for it to be tangent, so this is the center line or the radius point. This needs to be 90 degrees. If it's anything other than 90 degrees, it's a non-tangential curve. The curve isn't tangent to, or the arc isn't tangent to. It's the segments that it's connected. That makes sense? That's another reason why, okay, I'm going to shoot this point, this point, this point, because then I'm accurately creating those curves. Okay. All right. Let's talk about data loggers. Okay. So I am going to try using the document camera. Okay. Can everybody kind of see that reasonably well? Okay. If you all have a stylus that you use for your phone or your iPad or whatever, you can use your own stylus. You can use a pen that has a cap on it, right? Works the same. So the first thing you're going to do when you turn this on, you're going to see that it's registered to somebody. So you're not really so much worried about that. All of, I'm sorry, did you steal this from Scott? I did not steal it from Scott. Scott was kind enough to loan this back to Keystone Precision, who is loaning it to us, so you guys can use it. So this has a full license, meaning you can store as many points on it as you want. Okay, it's not in demo. Okay. One of the data loggers, I think the one that's going around, when you open it, it says it's registered to Roger Ruggles, who has retired. He was a former professor here. He used to teach this class. So, all right, when you open it, if you just touch anywhere on the screen, this is kind of like the home screen. Okay. Excuse me for 1 second while I share the screen. Is that it? Nope. Is there a way to share the document? Advanced content. Didn't advance. We're all advanced now. Sweet. Okay, so all of these data loggers, so you'll hear them referred to as data loggers, data collectors, and controllers. They're the same thing. Okay. These are old, kind of like me, but they still work. The newer ones, honestly, the main difference on the newer ones is they're larger, because when you get into this, you'll see that the little screen that you gotta type on is really, really small, which is why you need like a really, really fine point stylus to type to it. It's working, okay, and it's a full alphanumeric keypad. So instead of looking for a digital button, it's a button on the controller instead of those 4 or 8 names, okay. The newer ones also connect with Bluetooth. So you're gonna laugh when you look at these, because if you look at the bottom, they're old 9-pin serial port connections. They're not even USB. The newer ones, they all connect with Bluetooth. So when you turn the instrument on and you tell the data logger to start talking to the instrument, they just start talking to it. I'm having communication issues between the data loggers. I'm still trying to work out. I'll have it worked out before you guys go out, so that you don't have to deal with it. But I'm going to show you how to get started. The program that this thing runs on is the same now as it was 20 years ago. It's called Survey Pro. So to get this started, you go up to Start. Okay, see where it says Survey Pro, we'll click on that, and then it launches the program. Is that better? Okay, so the first thing you need to do is you need to create a file. Now, a word on file manager. I don't have 8 data loggers, there's 8 crews. Please, 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 please be careful that you are using your job. So when you go in the first time, you're going to create it. And when you go in successive weeks, make sure you're using your job. Is that not clear? Right? I don't want file management issues where, oh, I didn't save it. Be careful. Okay. All right, so to create a new one, down on the bottom, new. Honestly, you can call it whatever you want. You can call it the name of your building. You can call it your crew's initials. You can call it the date. You can call it whatever. Just make sure it's unique to your crew so that you know you're in your job. Make sense? Okay, so if you click on the job name, you see how that little keypad pops up? Right, that's what you have to type. Right, so you have a little caps button. So for what I'm doing, I'm going to say that my project is Marvel. Okay. When I'm done typing, just press something out here to make the keyboard go away. All right? Because you got to make the keyboard go away to see the next button. You all should be taking notes. I am recording this, but so you're not having 10 text messages. Not that I mind answering text messages or phone calls, but you should be taking notes about this. Okay. You should be able to do this on your own. All right, set your job name. You are not going to click this user import control. Its default is not selected, just don't select. Right? Put in your name and hit next. This is a once and done deal. You've created your job. You got to give it settings. North azimuth. Isn't that what the instrument does? North azimuth, generally speaking. Right. You could click that to south azimuth, you really don't want to do that because then everything's gonna be backwards. So don't change that. What distance are we using? Should we change that to like meters or something like that? Fast forward 5 years from now, you're in grad school. You're doing white papers. What should your units be if you're doing a white paper that's going to be published in an academic journal? Meters. Right? In the real world, we still use US Survey. It's just the way it is. At least in Pennsylvania. Again, depending upon where you're going to, country or state, those could be different. This is what I deal with in Pennsylvania. Units. Degrees. We're not going to change it. I just want to show you something. Does anybody know what they call angles in European systems of measurement? Do they use degrees, minutes, seconds? Nope. What do they use? Radians. Yeah, radians and gradients. But they say, instead of gradients, they say gods. So instead of degrees, they measure gods. Adjust, yeah,
What's the scale? Is it radians or how does it work? Because what is 360 in radians?
oh, I have to look it up.
You don't know.
I never use it. Do you know? It's in the text. You're hired.
And Google probably has it too. So
Google's your friend. I don't know. I never use it. I'm not gonna lie to you. Okay, adjust for curvature and refraction. Is that gonna make a Hills beam's worth of difference to what you're doing? Nope. You're surveying a couple hundred feet, tops. Right? In terms of, does it matter if that button is selected one way or another? Nope, not at all. You can select it, you cannot select it. All right, now here's where you need to be paying attention. This is where you're going to tell it your first point number. I don't care if you code your traverse 100, 200, 300. I don't care if you code it 1, 2, 3, 10, 11, 12, 90, 91, 90. Pick something. Right? I use 1 through 10. That's me. Are you wrong if you do 100 through 120? Nope. Just pick some. Now, everybody sees that this is an arbitrary coordinate system. I'm starting at 5,000, 5,100. Are your coordinates going to be 5,000, 5,100? They darn well better not be. What should the northing be somewhat close to? Come on. They're state plane coordinates. 260,000-ish, right? Or I'm sorry, no, 500,000. 500,000. What's the east thing?
2 million.
2.6 million, roughly. 2,600,000 something. Right? Those should be where you're at, northing and eastern. After you've translated your control over and you've gotten those points out of the CAD file, this is what you're putting in. Your elevations, as you dig your loop, should close. Your horizontal positions in your loop should close. If they don't, it's going to come out in the wash here.
Does that mean you want us to adjust it on that? Like when we find the error?
When you say adjust, you should be within 2/10 horizontal and 2/10 vertical, right?
We don't know.
Okay. You should be within 2/10 horizontal and vertical. Should you adjust from there? That's a discussion you should have later. You should be able to hit within 200 or 2/10 and 2/10. If you're off more than that, the data collector is going to tell you your backside's off. Okay. Elevation. Everybody knows how to carry the elevation. So you shot slope distance. You need to convert those slope distances to vertical distances. You need to know if you were going uphill or downhill. Right? People had problems with that on the test. And make sure you go back and review how to do that. And make sure you're reviewing your closure from beginning to end. Okay? Description. You can plug in whatever description you have, right? So let's say you had a hub. Okay, so to make the keyboard disappear, select anything that's white that's not a button. So that's my point number one. Yours is going to be different, correct? Okay, so then hit finish. So now I'm here. You are now in Survey Pro, the program. You have to tell it at least 1 point to get started. But you're going to have all 4, 6, 8 points of your travelers, right? Agreed? How do you enter additional points? Everybody see up top here, you got file, job, survey, stakeout, inverse, COGO, curve, roads, adjust. You're not going to do adjust. That's Jedi level stuff. That's least squares, adjustments, and traverse. We're not doing it. You gotta crawl before we walk. Does anybody know what COGO stands for? It's an acronym. Well, no, not really an acronym. It's kind of like a short half word. Anybody know what it stands for? It's a pretty common term in survey programs. Coordinate geometry. So when you guys took 2 angles to locate the Colton spire, intersecting 2 lines, you can do it in CAD, right? We're going to do it pencil and paper with calculations, which is going to be on the next test. And you'll see that CAD's a lot easier, right? That's coordinate geometry. It's called a line-line intersect. You've got a line, another line. Where do they intersect? Where they intersect for us is Colton spire. But everybody can kind of see how that would be useful. If you can't get the distance, all you need is 2 lines. You have different types of intersections. You have line arc intersections, where you have 1 line and 1 arc. You have arc intersections, where it's 2 circles, where you have distances, but you don't have angles. An arc intersection, how many solutions does it have? 2. Right? Sorry, I pointed to you, but you had the right answer. 2. A circle intersects twice. Right? There's 1 correct answer, which you need to, okay, which one is it? All right, so how do I select additional points or create additional points? I'm sorry. You click on job up here at the top. See where it says edit points? Second one down. Select edit points. Now, there's my first one. Let's say I made a mistake and hit enter. All you have to do is select it and hit edit, and you can edit. See that button right there? What does it say? Come on, I know it's Friday. Jeez. Insert. Insert another point. Point number 2. Right? We want point number 2. Location. Does anybody see how I got there? So when you get to point 2, you have 3 tabs on the bottom. General, location, geodesic. General is just the description. Okay. You could put it on a different layer. Just keep it set to points. You don't need to do anything with any of this. But to plug in your coordinates, you have to go to location. Northern, easting, elevation. Same thing for point 3, point 4, point 10. Anybody not okay with this? Because this is where we're going to leave off. I'm going to pick back up with plugging this into the instrument and getting these 2 to talk to each other.
After you put, after you finish things, and you
I didn't select it. I just kind of talked about the theory of what it is.
Oh,
You can do line intersections in the data collector where you're not doing it in front of a computer. But you have to keep things straight, like it doesn't give you the picture like CAD does. I think the first time you do it, you're better off looking at something visual like CAD. So I'm gonna stop this.